Okay, let's take a look at this problem. Reorder routes to make all paths lead to the city 0. So I tried this problem in Google's mock interview in the LeetCode, and I kind of failed. I tried to construct the graph in a such way that I have the answer, but the answer is just asking for the number of edge changes. Let's read the question so that you can understand. So we have n cities and from 0 to n minus 1. And there is only one way to travel between two cities. So it's a directed graph or like a tree. And last year, Minister of Transport decided to orient the roads in one direction because they are too narrow. The roads represent the connections like this: A from A to BI. So as you see, from 0 to 1, as you see here. And this year, there will be a big event in City 1. Many people want people to be able to travel to this destination, and your task consists of reorienting some roads such that city 0 can be visited with the minimum number of changes. So for that, like I said, I tried to construct this graph, but actually there's a much simpler way to do this, which is that when we create a adjacency list using dictionary, and when we are doing that, we also have two directional. We are adding the other direction as well, and then when we perform DFS, we check the if we use the new added edge or if we use the the edge that was there, right? The actual edge. So we will have. So let's show you. So when we have adjacency list, we will just put all these. So we will have like that, like that, like that. Right? It's like a double linked list. Uh, and when we start from 0, when we go this way, this way, this way, when we that first search, if those are the ones we're using are same as these ones. So how do we understand that? By maybe giving some marks, and then let's call this 1, this is the 0, or maybe like -1. The ones we added, these are the ones that are already there. So that way we will be understanding how many, we will be counting how many edge changes or reorientation is required. So for that, let's start and create the graph. So how do we create the graph? I can use default pick, which okay, I'm sorry. Okay. So graph can be default pick, and yeah, and this can be a list, and when we go over this list for every I in for every u v in uv in connections, we create graph u is equal to like append v, and the same thing with other way, like that, and you also have the count equal to 0, we will call the DFS here, and then return the count. Maybe we can do it like this, right? We change it in the we can just pass the reference like that and then change inside the array. Then so we have this graph like a double linked list, and then okay, just 1 second. Okay, so here let's create the DFS. We pass the, do we need the visited ones? I guess I have to check. Yeah, I need the visited. For that, I also need visited here. I need the visited. I need the counts. I need the graph, like here, graph. And that will be enough. But here, okay, I forgot to mark it. So okay, like this. So we'll have -1. So normally U points to V, and I will call this edge like this. It will be +1, and if it is -1, then it is I will. It means that we have to count it. We have to increase the count. And so here we will continue. So we first visit. Yeah, here for visited we can just have false for every I in range. And here visited and graph node visited node equal to true, and then for every neighbor in graph node, first I check if neighbor, like if it is not visited, if visited neighbor is equal to false, right? And then if it is false, if we haven't visited, then we check if edge to it is let's see, edge to that, this should be 0 by the way, because here visited neighbor 1 should be equal to, if it is -1, then we increase the count, right? Count 0 plus 1, and we run DFS visited graph count neighbor. Let's see. Okay, let's see if this is correct. And graph. 1 0 goes to 1, 0 goes to 4, but it is oh I made a mistake there, which is yes, that's the opposite way. And now we come here, we say that node 2, node is not visited. Actually visited node on that, that's 0, that's how many times do we go in? Print test. Let's see, we have to go in 3 times, but yeah, we're not going in. This should be -1. Let's see, we mark it as that. So for neighbor, if it is not visited, okay, I'm not calling this. Let's see. Neighbor 0. Okay. I'm not going into that. Okay. Let's test it with another example. Okay, and one more. Okay, so the logic was simple, but in my first try I couldn't find it. So I only had to find, so in questions like this, if I'm required to find only the columns, then I don't have to, like, I mean, in most cases, if the question is asking you to, find out how many number of that requires, that like the operation is required, maybe you just change this data structure in such way that those operations are performed, and then you count the differences between the previous one and the next one, and then it's much easier to find it, because otherwise like it's kind of really hard, because in my first initial try, I mean, I won't be uploading that, but I tried to start with 0 and 4, and then tried to change that and that, which required another list. I had few nested for loops, which were very unnecessarily complicated. So I made it require some more context than it looked. So it's better to think easy. Some cases. Uh, as you see, that's like to okay. So yeah, that was it. No, it's not a premium question, right? Okay. So yeah.